All right. More barcode stuff today. Here's our current state. Look, we take a barcode, we go, oh, let's make it small. Oh, let's find some edges. Oh, let's turn those edges into lower resolution edges. Let's like fucking put them together if the color in this picture lines up a little bit. Oh, there we go, we found one. Let's pull it out. Right, that's kind of current state. Um How'd you end up doing this? Machine learning or complicated algos? Neither. I mean, it's like algorithms for sure. Nothing complicated yet. We haven't got to the point where we're actually doing the barcode scanning. We've just kind of we did a little bit at first, but we've mostly been looking at like barcode extraction. What I want to do today is I want to look at so at some point we had some example that went line by line on this thing and like converted each line independently into basically black and white, depending on if it thought that it was like an edge was surrounded by black pixels or white pixels. And it worked like okay. And my thought was eventually we would go line by line and parse the barcode on every single line and then see if we had some sort of like consensus formed, maybe over multiple frames as well, right? But I realized that that seems kind of stupid. I think what we really want is we want consensus on like these guys, if that makes sense. Like we want to be able to use the information that we have, that barcodes have vertical shared information. In some examples, maybe it's this one. Hold on. I think it's this one. I actually haven't looked at this yet. But, you know, in some examples like this one, there's like a shadow here that sometimes gets detected as an edge. Right? And like there's like noise kind of overall in the picture. Right? Like there's like specklies and stuff, right? So like at some positions, like at this particular pixel position over here, right? In isolation on this row, you might be like, oh, you know what? These pixels are kind of bright, like, or like over here, right? Like these guys are kind of bright too, right? And so what you're really doing when you're looking at this with your eyeballs is you're kind of using like vertical information to say, hey, this is like one chunk of black. And so what I think the correct answer might be is for us to kind of get some consensus on like where a bar is before we do parsing. And so I kind of want to like fold this whole thing down into like 1 pixel tall barcode. That's kind of what I'm thinking. And so I think to do that, it would be nice to, I don't know, do some like statistical analysis on, I don't know, if we do like a horizontal edge detect and then say which edges are like agreed upon the most, right? Maybe we have like, you know, we should have like 96 edges that are taking up like the majority of the screen or something. I don't really know. So I want to build like a histogram of like where we find horizontal edges or something like that and display it. And then use that to like inform how we're going to like parse this thing. Are you scanning barcodes or making a histogram? I'm saying I want to make a histogram as part of the barcode scanning process, right? So like what we're going to end up doing is we're going to say like, hey, how many, given this X position, how many times did I think that there was an edge there? Right? And so what we should see is like, we might end up seeing stuff that's like, you know, this, right? And in reality, these are going to be kind of like small peaks because like there might be, you know, a little bit of noise around each of these edges or something like that. And so somehow we're going to have to like look at all of these numbers and we're gonna have to be like, okay, so you know, if there's like a small peak here, do we like discard that guy? Do we care about this one? Well, like it kind of depends on how big all the other peaks are, right? So I just want to like have a widget that I can use to like look at information like this. This is also going to be useful in terms of like contrast enhancement, right? So, uh, you know, we might, if we have something where it's like a low contrast image, but we're still expecting to see like two humps, we might see like, if this is like color or like brightness here, and here this is like number of pixels. You might see something like this, where there's like a lot of dark pixels and a lot of bright pixels, but you also might see something that's like this, right? Or in the presence of a shadow, you might see something that's like dark and then like some like kind of gray, some like kind of gray, and then some bright again. You know what I mean? And so like having something that we can use to look at this is going to be nice. So that's where I want to start today, I think, is histogram widget. This is also going to be useful if we ever go back to our image editor. It'll be nice to see that in there. But let's just start. Let's just start with making a histogram. So we need some data to put in the histogram. Maybe it makes sense to do this in our demo application that we were working on recently. So we have a GUI demo, and in here, maybe it makes sense for us to just kind of like make up some data. So maybe we make like a, can we like make like maybe a Gaussian distribution or something? How do you fucking make one of these? Normal distribution. What's like the formula? Here, standard normal distribution. Special case where u equals 0. What is this thing called? Is this sigmoid or something? What is like what is the name of like this character? Greek Greek letter O. Oh, is it omega? Small o? Can we like look up this character? No, it's a picture. I want to know what it's called, man. Let me know what it's called. Oh, here we go. That's pasteable. Oh, yeah. Oh, yeah. Sigma. Sigma. I was close when I said sigmoid. Sigma. Okay. So I just want like something that looks like this. Something that looks like this. If I recall, there are indications that state marked segments and codes, like leading bits in a binary. Typically, they blow out the contrast of the image, so everything's either this or that. This you need to deal with the gray. Yeah, but like if there's a shadow, you need to know how to like bias things low or high, right? Like I was seeing, especially in the context of with how do you call it? Noise. It's very possible for like a shadow to be as bright as like noise generated from something like this. You know what I mean? Like this noise here, you might want this to be coded dark, but then like down here, a shadow on some light is like maybe the same color sometimes. You know what I mean? It's like, I don't know if it's like so obvious of like how to blow it out. You know what I mean? Which is why I want to do some like looking, you know? That's all. I just want to look. Okay, I want a distribution to play with. So is that what this is? Also this, where, what is Z here? Oh, are these like the same? Probably not, but okay. Fuck, just give me a number. Just give me a formula, man. E to the negative z squared over 2. So z is just, this must be x-axis, right? Yeah, this is x-axis here. Yeah. So I rip this shit for some range of numbers. And at 0, it's peak, and then like left and right of 0, it's smaller. And then what we have, like minus three standard deviations away, you've got like the vast majority of fucking everything. So I guess this special case is that standard deviation is 1. Okay, so we rip this function from -3 to 3, I guess? Sure. Generate standard dist. And I guess we need to go in some, like, increment, right? We need to have some sort of, like, step that we're willing to take. So can we say here, maybe we just, like, have an output as a bunch of floating points? Maybe? Okay. So then we want like, you know, we want a bell curve with, you know, approximately 3 standard deviations. Filling output buffer. Thus, you know, standard deviation should be outlet like 1/6 of output len, I guess. Okay. Sure. So then we actually want the general form, and then, wait, what is... Oh, translation is U, which we don't give a fuck about. We're centering on 0. So, function is 1 over O. What the fuck is this thing? Oh, I see. This is the standard. This is this function. So they're saying, use this and then plug in this. Sure. Yeah, makes sense. So we want everything to be floats. I think that makes our lives easier. Yeah. I think we actually want to do this first, then center divide equals 2, like this, so that it's can be a floating point number if we need it to be. Same with this, actually. Yep. Yep. Okay. So I guess we have... What the fuck is this thing called? What is this letter? I wish I could highlight it. I want the letter. I guess it doesn't matter. This thing is called standard normal dist, which I just want to take in, I guess, Z. Sure, something like this. Okay. Phi? Is that phi? Is it the lowercase phi? Yeah, maybe one of them's... Yeah. Nice. So this is... I guess it doesn't really matter which one of these we use. Wait, hold on. This one. We want this one. These ones are the ones that it might be. It's actually this. E... Take e to the power of negative z times z over 2. Okay. And then divide this by the square root of 2 times math pi. Okay. And then, okay, so then when we're doing the non-normal form, we go, you know, standard normal value of, I guess we go like 4 out. Like this. And it's like I minus center, so x, you know, if as a float, I guess, is float from an I, so that we can do I minus center here without it being a problem. Okay, then we divide this whole thing by standard deviation, and divide this whole thing by standard deviation. That's what they're saying to do here. I'm not sure this is right, but we can take a look. So just up front here, I guess. Can we just call like generate standard dist in standard dist? Yup. With like 100 floats. Pipe. What doesn't he like here? Does this guy want like a type? Yeah, he does. And then can we print this guy? What did we make? Hopefully it's right. I don't fucking know, man. Can we like LibreOffice? Let me punch this into a fucking spreadsheet and see if it looks like approximately right. You know? Bum, 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 bum. LibreOffice. Discard, please. Yes, please. New spreadsheet. Paste special. Use text import dialog. Comma eliminated. Nice. Is there a transpose button here? No. But I think we can then do this and do like, give me a graph, sir, please. Tools. Dude, I know that there's a graph button somewhere. Is it over here? How the fuck do you use this program? This is the one thing I want to do in here. I could have sworn it was under data. Insert. Of course. Of course it's insert. Look at that. That's a normal distribution if I've ever seen one. Look at that. Look at us go. I don't really like where the max is here. Is it because I divided by standard deviation at the end there? Like, shouldn't this be scaled so that, like, 1's the max or something? If val is greater than max, max equals val. Okay. You know what I mean? Area should be 1, not the max value. Oh, that makes more sense. Yeah. Okay. That, I can get behind that. I can get behind that. So we should be looking for total here. Font, thanks for the prime. Much appreciated. Yeah, so this is too big now, and then because I deleted that divide by standard Dave here. There we go. Yeah, that's about right. Right, we have 0.997. I think that's the number I've seen before for like the amount that's within 3 standard deviations. Okay, cool. So we have some data to work with now. And so presumably we want this stuff to like go into a widget somewhere. Now, our typical widget pattern in this GUI framework, it's kind of like a hybrid approach of an immediate and a retained GUI. So we generate like widget, right? And this gets like fed into like some layout system, right? So like here we can like have a lot of widgets like this, whatever. But every frame, they're going to like call some function to like get new data. And that new data is going to like result in like a size change and like, you know, content change or whatever, right? And so we kind of do like re-layout every single frame because with new data, but we have kind of like long-term widgets that can hold like state between frames and stuff like that. So we need to follow that. So probably we need some sort of like histogram. And we call this a function because it's a generic thing. Hello, YouTube lurker catching live for the first time. Hey, welcome. This is usually like a GUI action, so these widgets also typically, they're not supposed to like edit state of anything. They're allowed to look at state, but if they want something to happen, they're supposed to return some action that you want to happen defined by the application on input, right? So if I like click a button, the widget goes, hey, he said that he wanted to like make the screen full screen or something like that. You know what I mean? And then we can like handle that how we want. So that lets us do things like in like a slider. It lets us like application specific decide to like clamp the numbers or like round them, stuff like that, because it's not like defined by the widget itself. Okay. So this guy, he's going to have some sort of like histogram retriever as well, right? And this is how he's going to get the data every frame, right? So if the histogram's changing over time, this is how he is going to get that. Okay. Actually, let's just do this in a histogram off rip. Okay. So then we can do like we'll figure out how to make it later. Okay. Now this guy is going to have to implement like the widget interface. So we have to pull that in. And this guy typically has like some other function lowercase. Which is going to have, I think, like this. He takes the action type and then the retriever as like an actual thing, and he's going to return a widget, if I remember correctly. If I remember correctly. Have you heard about the pirate software shitstorm? I mean, how do I want to say this? I know that there's like drama. I know Reddit, like LSF hates that guy. But I don't really care, you know? You know, I think that I've seen some people claiming that his code is shit, and it's like, fine, you can think whatever you want, but like those videos that are coming out that are like, he's so bad at coding, he used a number instead of an enum, he has two nested if statements. Like, who fucking cares, man? Who cares? Like, there's all sorts of reasons that you might not like the guy, but him writing, you know, four numbers instead of a for loop is like, in a fucking single man owned code base is like not. It's crazy that like if you're gonna critique someone, critique them for something reasonable, you know? Where I think there's probably a big list of stuff that you could pull from. That's all I'll say on it. Because I don't really want to get more involved than that. Okay. So this guy typically implements like a widget interface, if I remember correctly. So we have to somewhere we like create our histogram, and he will have functions on him that do widget actions. Probably for now we will only implement the ones that are mandatory, but I think the rest have to be explicitly null or not null. Okay. So I guess we need like function render. We actually have this right here. Why am I fucking retyping when I don't have to, you know? Okay. So what the fuck does this shit do? Pixel B box is GUI pixel B box. We got pixel size here as well. Boom, boom, boom. And on render, we're gonna do something. This is like render the histogram. Right? But let's get our V table set up first. So this is a widget action V table whose render is render, get size is get size, and then I think we make ourselves explicitly null out the rest to be like, I opt in to not doing these things. So macro dot equals null, boom, 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 and then we'll get to the rest later. Okay. Okay. I guess we'll write unreachable here for now until we implement. Okay. So now we can just say like our histogram type is histogram with our action and type of retriever. And then we should, I think usually we need an allocator in here too, because this thing is returning a widget. This widget holds a context. You know what I mean? So we have to have like a context pointer is like some histogram pointer, and then the V table is this. Boom. So now we just have to implement that. So I guess this guy takes in an allocator. And he is allocating himself. So we make a T. And then we put the context here. And we put our retriever in here. Nice. Okay, everything's starting to come together. Bing, bang, boom. Yeah. Okay. So we should be able to go back into our demo thing now. Usually things come through this like widget factory. That's where we make everything, because there's like a lot of like shared state that gets passed around. So this guy having a function here to be like make histogram is not unreasonable. So we would just return, like, I guess this is where histogram lives. We need to, like, import this thing somewhere. Boom. And now this guy can be, like, GUI histogram, histogram, with action, our allocator. And retriever, which we haven't really figured out yet. Which means retriever needs to go here. And then that means, you know, where the fuck we were, demo. We can do something like widget factory make histogram with histogram retriever. And what we need to figure out is, what is that interface? What makes the histogram go, I've got new data? You know, I guess for now, so what are we going to actually try to draw? That's what's important to figure out here, right? I guess, like, it would be nice to have, you know, we're going to draw, like, you know, a bunch of bars, right? And these things are going to be at, like, you know, known buckets. Right? Maybe having axes here would be nice. Maybe just one axis, where we want to show, like, maybe, like, the bounds of this thing. Maybe. On hover, maybe you can, like, you can hover one thing and have it, like, show the number directly here. Would be kind of nice, maybe. Right, so this would show, like, 0, 0.3, and then as I, like, drag my mouse over different bars, it shows, like, different things. Maybe. You it looks like a middle finger? Fuck you. Yeah, because I don't really want to have to, like, figure out how to, like, you know, render every single element here, because as the number of elements grows, this gets to be a pain in the ass. So I do like the idea of being able to hover to show an individual one, and then just show the bounds normally. Yeah, so here we need max here to normalize height. I guess we want, right now our thing has a bunch of, like, sample, like, this x-axis here, right now with the way we've generated this data, doesn't really know, like, what values each bar is associated with. Right, so we probably want, like, x vals, right? Y vals. Or I guess, yeah, we do need all x values, technically, because for the hover thing, maybe you could, like, easily, like, calculate that based off a range if you assume that the values that come in are evenly spaced. That's, like, kind of reasonable. So we definitely need, our retriever definitely needs to return max, y values, and then either range or x vals, one of these two. So let's start, I guess, like, technically also you could determine if your y values, like, you don't technically need to return the max if you're, like, happy to walk this. Yeah, so maybe we don't need this. Maybe. And we need some way to, like, determine if the histogram has changed. Because we only want to, like, regenerate our GPU buffers to, like, render each of these boxes in the case where the data has changed. So having, like, a data generation maybe makes sense. or like some hash of the data. So either we like opt into explicitly saying it's new or not, or we could say like wants update. I think a generation makes sense. I think like data generation makes sense. So this is going to be like histogram retriever. Can I use your text rendering code in MIT project? Your post license? Yeah, go ahead. I don't give a shit. I should add MIT license to everything. It's like I really just don't give a fuck. I guess I need to pick something though, because I would be like, I know that I would be annoyed if somebody was like profiting off my work in a way that's like, maybe I like, yeah, I have to think about it. But you're good. You're good. I'm pretty sure. I guess like that's the point of the MIT license though, is that you can't stop someone from doing that. So maybe I just have to like come to terms with the fact that I don't give a fuck, because I don't. Add a license says contact me. Yeah. Okay, so I think it's gonna be generation, data generation. I think generation is fine. U64 is like don't run out, right? Like U64 max is this. I guess it's like how many nanoseconds fit in a U64. $584. So I'm chilling. I'm chilling. Okay. I guess here we'll just return 0, because like ours doesn't change. Maybe what we should do is have like a randomized button that lets us generate new data. How much time, not how many nanoseconds? I mean, the unit matters, right? Because you can fit more time in a U64 if your unit is larger. I had a server that almost had that update. Time, yeah, exactly. Okay. Yeah, for now we'll just return 0 here, and then we'll figure it out later. Data, I guess. Why buckets? What's like the best name for this? The best name. What's like a reasonable name for this? Like name for each column in histogram. I'm just gonna say Y values. Y's. Sure. You guys are saying buckets. But then the thing is, like, these buckets are... A bucket is, like, a more defined than this. You know what I mean? Like, I think that a bucket is Y val plus X val, you know? So I think having Y values its own thing is, like, fine. A bucket has an X as well. Yeah, that's what I'm thinking. So I think that we will get Y values. That's fine. Okay, so that means that we're gonna have to take this belongs in update. Like render and get size are things that like can't fail. Update is like a failable thing. So here's where we're supposed to do like any like real data processing. You know? So let's start here. So here we're going to say like, hey, we have a context. we need to convert that into like ourselves. This is a pointer cast, a line cast of context into a self pointer, where self needs to be defined. So this guy's also in charge of like figuring out his size. What is like a reasonable thing for us to do in terms of size? I guess like it's probably fixed, right? We could also expand to fill available space. And then we have like utilities to like clamp that if we want to. So yeah, let's do that. Let's just expand to fill all available space. Fuck it. Fuck it. Yeah. I think that's like the thing that works best generically for now. Okay. Boom, boom. All right, cool. Okay, so that's that dealt with. But we also have to like render the bars. So I guess we like say self retriever y vowels here. I guess we say last generation. I guess this should like maybe start as like max int for a U64. Then we can say like if our last generation is not equal to IE or EI in retriever. IE. Retriever generation. If this is equal, we say fuck off. We're donezo. A U64 can hold 21 human generations of nanoseconds. Hope this helps. Perfect. Thank you. That is a fuck ton. Your great grandfather once said, "Patch my GUI framework," and now it's a burden that falls to you. Yeah, it's like those TV shows or like fantasy stories where they're like, you have like the family line has been passing down this story for like 50 generations, and now like you're the one. We did it for like patching our GUI framework. It's perfect. Max Y. Is this a histogram? I mean, it is a histogram, but are we just making a bar chart? I feel like we might be, because like the fact that a histogram shouldn't have floating point numbers here, right? Like, if you're counting stuff, fuck it, let's just not think about it. For Y vowels, I'm sure we're going to be doing many things here. But one of the things that we're going to be doing is checking the max. 0. Then here, max y is the max of val and max y. Simple. And we probably also want to like generate some GPU buffers here. So what are we trying to render here? Each of these is going to be 4 points in a quad, right? Bottom 2 points are always at y0, but they do have like different x values, right? So it's like we have to find the range of x's, which we don't actually care about right now. because we know that like the leftmost bar is going to be drawn on the leftmost edge and the rightmost bar is going to be drawn on the rightmost edge, right? So we have to just convert these to like each value needs to go into like OpenGL coordinate space where this is -1 and this is +1. Okay. So to like make GL points or something, right? So we're gonna take some like max x probably, as well as our x position or like index. Num items is probably like the better name for this. We have our y and max y. I guess, yeah, we can't generate the bars until we know the max value. So we have to do one pass to get the max, and then we do a second pass to make our OpenGL buffers, I guess. Wouldn't a texture make more sense? I don't think so. So for a texture, you would have to like draw every single pixel on this thing, right? And then display that. Having OpenGL just draw the shit for us is easier. Cause like, he just can like, it's really easy for him. Maybe you could draw to a texture once and then display the texture, but this is the type of shit that I think is like, not hard for the GPU to do every frame. So I think it's just worth doing. This has to be made out of 2 triangles, right? And so I guess like a question is, do we need a custom shader for this, or can we use one of our existing like super simple ones? We have a XY plus transform program that allows us to plug in any fragment shader. I think that's all we have here, right? All we care about for like geometry is XY positions plus transform. Ooh, and we can actually feed the data as is almost. Yeah, you know what? We can do all this work on GPU. Once we have the maximum. Because we can just set the transform to normalize this stuff. Yeah. So we can actually... Okay. Data layout on GPU. I think we're gonna have a program... Hold on. So vertex shader takes in X, Y. We have this laid out in GPU memory as X's as a buffer and Y's as a buffer. And you can feed these to OpenGL as like separate parameters that go into one shader program, if I remember correctly. I have to go through some history to figure that out, but I'm pretty sure that's possible. And so what we can do is we can just like yoinkies our X values and Y values directly from the retriever. No, we can't, because we need 4 points per bar. We need 4 points per bar, which is, I think, not as trivial. You can make that with geometry shaders, but I think those are slow. Okay. But we can still do this as, I think it still makes sense to just do this in pixel space, because then we don't need to loop over twice. I think that's slightly better. So let's do this. We just do X index and Y value here. And this is going to return 4, probably like vec2s, probably. Except these probably want to like have like a specific format to go into our shader. Let's take a look. This guy has XYT program who wants these guys to come in as vertex. So this is going to be like, give me 4 render XYT program vertexes. Yes. You're asking for y times x percent width, and that's your source, but now I'm just describing a geometry shader. TL, they're slow. I mean, I've heard that they're slow. I haven't actually ever checked. I think people don't like them. That's all I remember hearing. And at the very least, I don't want to take on that complexity, because I know that they're supposed to be replaced by something else. Mesh shaders, I think, is the thing that's supposed to replace them. And I'm like, if there's like a replacement, then like I don't want to learn them, and then it's just like, you know, I can just generate this on CPU, whatever. So we need 4 points. Tessellation shader, that sounds familiar as well. So I guess we have, we actually need 6 points, because this is gonna make 2 triangles. 2 triangles. So we have top left. Can we actually do this? I don't want to type this like 40 times, you know? You know? 6 vertex. Okay. So I think it's just like, I guess we do need num x items. Actually, we can do this now, normalize this from -1 to 1, and then only normalize y later. Because we have all this information easily up front. So x width is num x items. Let's think about this. If I have 2 items, this is -1, this is 1, which means that we have like num x items over 2. Yeah. I think that's right. I think that's right. I guess it's just num items, actually. Num items, boom, boom. And then we do like this. What am I doing, dude? Divide equals 2. There you go. So this is like 2 bars with 2 bars. Each bar takes 1.0 width in OpenGL space. Okay, so this is like bar width. I guess like we want like half bar width is actually what's going to be happening here, because we're going to be like finding the center. No, we're not, because the index is left aligned, so x you know, over num items is left edge, I think. So left, so divide equals num items, also float from int like this. Okay, cool. Right is left plus bar width. Cool. So this is just like top left is, you know, left y. Can we do this? Top right is right y. Then bottom left and bottom right are left and right 0. You know what I mean? No, not true. -1. No. 0. 0, because note y positions are in 0 to max y will be normalized to -1 to 1 in transform later. I think that makes sense. This allows us to generate points before we have figured out the maximum value. Yep. Cool. And now we just need to make our triangles. So it's like we want to go clockwise, I think. So bottom left, top right, and then bottom left, top right, bottom right. That makes us 2 triangles. That's this and this. Cool. Cool. So now these have to go somewhere, presumably, right? So probably what happens here is we have like a vertex array that we're supposed to work with. Render source is what we call this thing. And then render data is buffer here. Okay, so I believe what we're supposed to do is these guys are basically the OpenGL mappings in our program of vertex array and vertex buffer. And so I think that we create this guy once mapped to this data. This guy has like a bunch of extra parameters, but basically he's just like OpenGL handle to a buffer, kind of hand wavy, as well as like how that buffer is laid out in memory and how it maps to the program inputs, hand wavy. This guy's like just raw data. And so what we're going to do is when we update, we're going to update render data, and the render source should be set on initialization, I think. So we have like an OpenGL pool allocator. So this guy is now going to be a render allocator, which holds like a heap allocator and a GL allocator that kind of like live for like the lifetime of this widget. So here we can kind of do this now. So you're just rotating it. Isn't that where computer viruses come from? Yeah, they're like data transmitted. DDTs. DTDs. Data transmitted viruses. Wait. Diseases? Data transmitted diseases? Anyways, it's whatever. So here we also need a pointer to a program to render with. This XYT, no, we're gonna make our own, actually. We're gonna make our own. Because we have to define our fragment shader for this thing. So our fragment shader, let's just for now like make it blue. Later we'll probably highlight one bar depending on if it's hovered or not. We'll have to handle that part later. But for now, let's just do, you know, the default one. So I think it's like version 330 core or something. I don't remember. And then like void main like this. And then here it's like out is equal to blue or something who gives a fuck. So vec4 RGB alpha like this, and we define out. So I think it's like vec4 out vec4 fragment. I just think this is what's supposed to happen. And this is like a program that's running on the GPU for every single pixel, we'll say in quotes, that are in the box, right? So what's going to happen here is we're going to draw like a triangle for the bar, and then OpenGL will draw this triangle on the GPU, and he's going to iterate every pixel in here and get like the color for that thing. And so that's what we're doing here. So we should just be able to like be like, give me program is, you know, our program with uniforms initialized with our GL allocator and our frag shader. Okay. Uniforms. This is like just things that are common for all pixels or all vertexes in the scene. So the thing we have right now is just like a transform that's like a mat 3x3, I think. Yeah, something like this. Something like this. This thing I think has to be tried because it can fail because it's doing allocations, and we need to like make an array out of this thing as well. So we need our like render source is XYT program render source in it with our GL allocator. Fragment. True. Thank you. And then data. Render data is what we called it. Okay. So then we say like render source bind data given our program handle and the render data. So big for us right now. So big. And then we just shove all this shit in here. Program is program. Render source is render source. And render data. Now, this is actually wrong. We should make one program can be used for all widgets, right? So if we have like 10 histograms, we should be using one program to render all of those. So we're not like regenerating this, like we're not like compiling this program like 10 times. That's stupid, right? So we usually do something that's like shared data here. And he is the guy who owns this program. And whatever other parameters are shared between all instances of this guy. And then, he comes in like this. So this guy also takes in an allocator that he needs to live for the lifetime of. So this is a GL allocator like this. And we just kind of move this here. Program is program. Easy. I guess this can just be done inline like this. Oopsies. Paste, comma, like this. Huge. And then this can fail because we have an allocation inside. This guy then says shared is shared here. Pipe, pipe, pipe. This comes from shared program here. Everyone's happy. Everyone's happy. Okay. Cool. So, as we are iterating all of our points, we find the maximum value, and then we also make GL points for this X index. Right, so here we're like, give me X index, hit me with the number of points, so Y val's len here, and then my val. And I guess we want to like push these somewhere. So we need to have some sort of like scratch buffer here. Yeah, so we have like total points, like we know that this is going to be 6 times the number of elements in Y vals, right? So we can get away with like a util. We can kind of like pre-jack this where we can say, this is a runtime, say a bounded array of vertex initialized with some like scratch. Probably comes from shared. Is probably where we've done this before. Yep. And we have how many points? It was 6 times y vowels len. This is how many of these things we have. We want to checkpoint that thing, so we say scratch checkpoint and defer restore of that checkpoint. We'll do our best effort to not use more memory than we have to, but you know, we'll use some. Then we can go for each of these, you know, bucket points here. We can say like points append slice of bucket points, like this, hype. And then at the end of this thing, we can just say render data, update buffer with all of our items, all of the points. So this should give us all the data that we need to do rendering. I guess we also need to apply a like Y scale to the like transform, but I think we can do that on render as long as we write down max Y here. Right, I think that's all we gotta do. I think. Cool, so our shared also needs to have scratch in here. What is it called? Here. Okay. So now we need to make sure that this is like getting constructed correctly. So in our widget factory, this is why we have a factory at all, is that we can kind of have like some global state or some like global state that is shared between all widgets. So we're gonna say, hey, widget state now is going to have shared state for histogram. Right? And then we can, you know, shove that shit in here. GUI histogram shared initialize with, you know, where's my, it's GUI alloc GL as well as our scratch alloc. I assume that this is allowed. We must be doing this somewhere else. Yeah, like we do this in GUI text shared state. So this is like already an assumption that is made, is that this scratch allocator will live for a really fucking long time. Cool. Scratch here. Huge. This is tried. And then make histogram, we say self histogram shared. State maybe. Yeah, nice. Nice. Okay, things are starting to come together. Let's see how fucked we are on build. We need to make our histogram retriever true. Okay. Cool. Cool. We're getting somewhere. I think it's like this. And percent here. Try here. And then we have like histogram is this. This histogram has to go in a layout. So let's do this. This label gets appended to the layout. Push widget of, you know, this. And then we push this as well. Boom. Okay. And then we use the layout here. Boom. Okay. These things can fail, so we don't freak out. This guy needs the whole shebang, not just the heap allocator anymore, but he needs a GUI allocator as well. This can fail, I guess? No? What's he pissed about? Maybe this thing has to be a variable for this to work. Okay. This is a function, not a thing like that. And then what are we missing here? Max Y, sure. What is this thing mad about? Name is histogram, I guess. I think that it was a mistake for us to put a name in there, but whatever. This needs to be try, true. Whoa, what's he pissed about here? Oh. Is this the wrong thing here? Yeah, true. I just forget to write vertex there. Okay, so this builds, and presumably we will see nothing of value, right? Which is good, because we're not actually attempting to render yet. So we need to call our program, I guess, and do something with it. You know? So we like render our render source here. With our options, right? So here we need to say like our transform is probably like, so we need to scale, 0 to max Y to -1 to 1. And then after that, apply like, render in where widget lives in window. So we have this like, because -1 to 1 is like the entire OpenGL, our whole window. This is like -1, 1, 1, I guess here. -1, -1, 1. And we have like a widget in here, which we are also considering -1 to 1. And so we like kind of work in this space, and at the very end, just kind of like go like whoop. And it's actually kind of the other way, right? It's like we take what would be the full screen and kind of like move it, squish it down into where the thing actually belongs. So it's like window, widget to window is gonna be widget to clip transform is what we call this thing, I guess. So we say this is where the widget lives in the window, boom. And then all we have to do is say, like, Y scale is going to be some sort of, like, scale, I guess. So we say, like, X, no scaling to be done, but Y, we have to divide by max Y. So this is, like, 0 to 1, right? And so then we actually want to subtract 0.5, I guess, and then double it. We can do 2 here, so that then we just subtract 1, I think. Translate 0, -1. I think that gets us in the right space, right? So we squish it down so that it's too tall, then move it down so that it's a -1 to 1 instead of 0 to 2. I think that's right. So this is like Y scale, then widget to window, which I guess we can kind of do all at once here. Like if we kind of like write this out kind of like this, we can say 0 to max Y goes 0 to 2. Then here this is 0 to 2 goes to -1 to 1. And then we have this stuff. Boom. And we say here, like, put in widget area. And that makes this easier. Okay. Okay. Sure. That'd be cool if this worked. There's like a good chance. But instead we see nothing. Nothing at all. So can we... I guess we need to start debugging. Right? It's the only answer. So I guess first, let's see if this update function ever runs. You know, we'll say, assigning points. Like, is this doing anything of interest here? Looks like it. I don't like that it's spamming. That means that we forgot to do last generation is generation. Next generation. Boom, 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 boom. Okay. Cool. So it looks to me... Okay, so I guess we should double check that these points, like, this looks wrong, right? X position of 5 is, like, way out of bounds. So we've managed to fuck this up somehow. Yeah, bar width num items over 2 is crazy. This should be 2 over the other way. So that could have fucked some shit up. Let's see if that looks a little bit more reasonable. So now this is, you know, in the range of 0 to 1. Right? We can see the X positions should be working towards, like, 1 almost, right? We do see this, which is good. We also should see that the X values are, you know, they're... I guess, like, or the Y values, these will be converted later, so that also should be fine. Can we, on render, can we, like, rip a few points through this transform and just see what happens? So can we go, like... I just want to know, you know? So can we go, like, 4 points items, point, we can say, like, transformed point is this. And it's like, transform, apply on, point 0, v pause 0, point v pause 1. And I think it's 1.0 here is what it's expecting. I think something like this. Something like this. Okay. So these are, we do see X very nicely going from 0 seems wrong here. Yeah, that seems kind of wrong. Yeah, I guess it's because here our left is X index times 2 minus 1 to get us into, like, negative 1 to 1 range, I think. I think. Okay, so now he ends at 1, and he seems to start at negative 1, so X values are looking good. Now, Y values, we should be seeing 2 of them on the bottom corner here, right? So we're seeing, like, negative 1, and then these 2 guys are his height. Right, so that seems pretty right. And then we should be seeing 6 points per thing, right? So 1, 2, 3, 4, 5, 6. So the two corners of this bar should be -1 and -9.8. And so we're seeing this, and then this. Yeah, okay, so that seems right as well. But we're still seeing nothing here, which is concerning. Okay. So then, why? I would like to just render a box, right? If we can just render a big box instead of like all of this special data, then that will give us some more clues. So here, can we just say, you know, render data, update buffer with like, can we just draw a triangle in here? -0.5, -0.5, positive, and then like 0 positive or something. This should make a triangle in the middle of the screen, which we're not seeing. I guess we should be doing this with no transform. Right? Like, just fucking, like, who gives a shit, dude? Just, like, clobber everything. I don't give a fuck. So that's not happening, which is a bad sign. I wonder if it's, like, here, the, like, render source needs bind data every time? You know what I mean? Like, maybe we have to call this again? Oh, there we go. So that's kind of surprising. So, like, what's going on here? We bind data by calling GL vertex array vertex buffer with this guy. And we, like, what is happening here? We have buffer passed in, and we, like, look for the name of the thing in that buffer data and apply the binding. And so is it that, like, the buffer is changing when I call update buffer here? Or did I never call bind data? I did. I called it right here. So, like, yeah, I guess every time the data changes... but, like, this buffer has, like, a constant address. We're never regenerating it. So I'm surprised. But I guess it is what it is. Yeah, that's surprising to me. Okay, so we go back to trying to render with, like, the proper transform and the proper data. That's not bad. That's not bad. That's a fucking... And it, like, we're probably like, woo. Okay, so that's our data. Now, I don't like the way that looks. We also need to handle, like, axis drawing, right? I think that, like, we said we wanted to do something like this. So how do we do that? It means that, like, this stuff needs to be offset by some amount, right? Right? If we want, like, this. And then also, I feel like I want the bars to be kind of, like, do we want them to be independent? Like, how do I say this? How do I say this? Like, does it look better if the bars have edges to them? Paste, please. I don't like how I have to do this multiple times sometimes. But, like... okay, so let's say that we, like, color these things in kind of like... I don't know. Like, make them like this color. Ew. There we go. And then, like, what I'm not sure of is if we want some sort of, like, you know, uh, does it, like, look better if these guys have, like, this? Or maybe even if they're, like, spaced out a little? Yeah, like, I'm not sure. I feel like this looks better to me a little bit. Um, but then, like, the thing is, if these bars get really narrow, then these lines are going to be a little, like, they're going to dominate. So I think maybe it's fine the way it is. I think that it'll feel different when I can interact with it. Right? I think. Um yeah. And then let's also, like, we can also go and, like, kind of increase the number of samples we're willing to use as well. You know? Like, say this was going to be something like, for, image stuff, right? Like, you're going to have something more like this, where the edges are going to be kind of, like, less easy to see. So I feel like this looks pretty good. That looks fine. Let's pick a color. So I think that maybe we have some, like, colors in widget state already, kind of like global colors for the whole everything. I think our typical pattern here is we allow override. So I think our typical pattern is that colors go in the shared style. So here we get, like, we probably want, like, default color and active color, probably. What are the GUI color? Okay. So then when we, like, construct this thing, we want, like, colors here, I guess. Something like this. Boom. And we're going to have to, let's think for a second. So I guess our fragment shader needs, like, color, like, yeah. Uniform, vec3, default color or something here. And so then we pass in default color here. Our uniforms need a default color thing here, which will get auto-converted by kind of, like, our OpenGL wrapper system. And so all we really need to go here is, like, default color here is equal to shared default color, right? My guess is technically a vec4. Okay. And then here, can we go, like, this guy's, like, default color v4 is, vec4 of, like, just RGBA. Do we have, like, 2 vec4 on this guy? No. But maybe we should, but whatever. GBA. Okay. And then here, I guess we pass in, like, style colors, default color, style colors, active color. Or hover color is probably more what we'll be doing, because we will be hovering. What is he like here? Vec 4, my bad. We don't support vector 4s in here yet, but that should be easy to fix. So when we see a vector 4, we convert that into a float 4, which means that we need like a float 4 from somewhere. Right, so this comes from here. We need float 4 is 4 F32s, probably here as well. And then somewhere we're going to end up using those to like pass them into OpenGL program somewhere. Uniform type doesn't exist yet. It's fine. Okay, so somewhere this is what? We are binding, we are extracting values from a shader. So this is like, give me 4 of these guys. Get uniform FV. Oh, I see. So this assumes that like if the thing is 4 floats, then you have enough memory to access those 4 floats. So it's just simple like this. And then here this is specifying the values. So float 4 presumably is just like this. Presumably. Okay. Hype. Fuck. That's not good. So this could be broken in all sorts of ways. All sorts of ways, which is kind of fun. Okay, let's start by assigning this a default value in the shader. And if, you know, it's broken. Okay, so white is working, which means it's probably assignment of this uniform is broken in some way. Which is annoying. So let's do here 1.0, 0.0, 0.0, 1.0 here, right? Because that should let us know if it's red, then that means that we fucked something else up. It's white, which means that it seems to be in here. So this guy says, let me render with these options. This eventually calls render with triangles. These options end up here where we say, hey, let me resolve this uniform type here. Okay, cool. So what would be nice here is then we like apply uniform at location here. And we might like, it would be interesting to know if we're calling this applying uniform, because we might have forgot to pipe something else here. It's very possible. Zig build, zig build. There we go. Yeah, so the fact that he's not saying that is an indication that something's fucking wrong, right? So I would be interested to know, can we print known uniform locations here? So this guy's supposed to like walk all of the uniforms in this program and say like, oh yeah, this guy's like number 4. And like, let me apply that. So can we take a look there? It's possible that he chooses to ignore anything that has, it might be that he's like, he sees like, oh, Vec 4. And then he like doesn't know what the fuck to do with that. That's like very possible. In fact, I think that's likely. I bet you that's it. So if we're just like, let me look at shared program inner known uniform locations. I bet you that this is going to have one thing, and it's going to be the transform. Yeah. So here he's actually looking for the known uniform, but he like gave up, right? Which I think is probably something that we should log on. No, because there are cases where that's normal. Because like the uniforms get like fully optimized out, and then if you don't use them, and we don't really want to like freak the fuck out in that case, I don't think. So I think that's why this is the way it is. It's just annoying. So how does he resolve this thing? He has a program uniform iterator who what? He says, let me get a uniform for probably index. Yeah, so he walks all of the uniform indexes, and he says from GL type, and this probably logged and we just didn't see it, I bet. Yep. So we actually did this, we actually have the guardrails for this, and just forgot to look. All right, let's try that again. Yep, okay, so it's red now, right? Fuck, it's red now, which means that the color passing is working. And we should be able to then go back to the correct color here. Okay. Yep, there we go. That is our default color, baby. An ugly default color in this context, but it is our default color. Okay. Okay. So, what's next? We gotta like, we gotta make it so that when we hover it, we see something interesting. So at the very least, let's highlight the one we're hovering. Which means that probably in our shader, we want like a, hovered, something like this. Like, int, maybe. And then we want to check if, like, some input, and then we can say, like, we have the active color, right? And we can say, like, if index is equal to hovered index, fragment is the active color, else it's the default color, right? That's kind of what we want in here. But our vertex shader needs to like pass that information along somehow, which we are not doing yet. The range of the bin and the count question mark? I don't know what you're asking. So this means that like we've outgrown the default XYT shader, which is like just like a shader that works on XY position plus transform, right? We've outgrown this thing. We also want to have an integer of index, right? Which means that our vertex, where the fuck am I? Yeah, this is right. Which means that our vertex type here now, it's like, we have like our own custom program now. So this isn't just like a normal XYT program, this is like shader program, who is initialized with a vertex shader. Show what values fall in the hovered bin, its absolute counter, its percentage of its normalized. Yeah. So I think I'm gonna show, what I was going to do was later, when I get axes in here, I wanted to show like, how do I draw this? I was thinking like you have this, and here you show like hovered X and hovered Y. Like you kind of like usually show like the full range of values, but then like you replace that with whatever's hovered if you're hovering, was what I was thinking. We gotta start somewhere. Okay. So this is shader program now, like this. This handle is no longer a function. And I think we're chilling. So now we also need to say that we have like an output here. Out int index. So this is vertex index here. Yeah. And that means that, like, somewhere this guy needs to be, like, his own definition now. So we have vpause, which is vec2, and then index, which is an i32, I assume. I actually don't know how this program, like, somewhere, I think on bind data, no. When we, like, set up the render source from the bound data here, when we call render source bind data, this is where he iterates fields of the vertex type. And he's looking for binding index of this thing. And then he says apply attrib format. So here he looks for if it's, you know, short, byte, or int. If it's int, he calls int. So I think we're chilling here. I think technically probably it's better for us to call cint here. But I think it doesn't really matter. And then, like, does he just use that field? Like, fuck it, you know? He gets the offset of this field. Does he not use the type? That's kind of surprising. Yeah, he doesn't use the type here ever. So he just assumes that it's like, okay. Yeah, he works off of the OpenGL type and just hopes that your type matches. Sure, fuck it. Render source here needs to be of the right type now. So this is shader program render source and shader program buffer, probably. I think I probably want like a typed buffer or something. What are we looking at with like buffer in here? Buffer here. Yeah, it seems fine. I don't know why whoever's mad is mad now. Oh, is it because buffer needs a vertex here? Yeah, he does. Understood. Understood! Okay. So now we're in the generic shader program type. Boom, bang, bang, boom. What is this about? We need vertex here now. Sure. And here. Okay. And then these guys are missing index now. So this is just like v index actually is the correct thing here. Yeah. That's what we called it. The names have to match. They have to match or it doesn't work. So I think we just go like this on all of them. And I guess we can say x index c is a c int equals std math cast to c int from x index, or else return error too many buckets or something, you know? And then here we can do x index c on all these guys without anyone getting mad. Ooh. Interesting. Unimplemented signed GL type. Surely it's just the same, right? Surely. Where is this used? This is like to_GL type used here. Okay. And then is GL type passed here. So we really are looking for like, what does this guy want? Type is looking for these guys. So if we have unsigned byte, unsigned short, unsigned int, then the equivalents here are byte, short, int. Okay. So I guess it's just like the same as here, and we just like delete the word unsigned. Pipe. Okay, if you say so. Okay. And then we kind of say that for this switch case where we pass in the I, I'm sure that this is valid for signed versions too, right? Ah, fuck. We can't do it like that. Okay. There. Maybe. If fragment input is an integer, then must be qualified with flat. Sure. If you say so, I agree. That means that, like, there's no interpolation between it because the GPU just, like, can't fucking do that shit. Wait, what the fuck? Oh, it's here, in flat on the fragment shader. Maybe it's flat in, I don't fucking know, man. You can't fucking tell me. Must come after blah 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 blah. Must come after precise invariant interpolation layout and auxiliary. Oh, so he wants the storage qualifier int to come after flat, I think. Vertex shader output does not, so we need some match. So the input and the output need to go together, I guess. Or else we can't link. Okay. Now, I do not see any hover, but that's probably because we're not setting it, right? Hovered index needs to be defined somewhere. So that was a uniform, right? Hovered index. Okay, let's just, like, put 5 in here for now, just to see what happens. You know? Because we haven't, like, hooked up anything yet. But I just want to see that, like, it works. Which means that our uniforms here need a hovered index here as a cint, I guess. Needs to match. Maybe that's going to cause some fucking problems. Yep. So where we added float before, we need, like, cint goes to int, right? And probably, like, I32 is here as well, to be honest. Okay. Now, presumably we have the same problem where going the other way and looking up the uniforms needs to resolve, you know? Fuck. Right, like someone, it was like program uniform, uniform iterator. You know what I mean? It was like something like that. Program uniform iterator, here. This guy from GL type here. Oh, he's chilling. He knows how to find ints. We just didn't know how to make them here. Okay, so we're chilling, actually. That's actually great. Why is it still saying applying uniform every time? That's fucking annoying. Up. Am I in the right folder? No, that's why. I see. I see. Okay. So something's wrong here for sure. And I guess we gotta figure out what it is. So I guess we're gonna go back to logging that, like, known uniform shit. Does he know that that uniform exists and what location it's at? What was this fucking thing called? Why is it not resolving anymore? There we go. I don't know what the fuck was going on there, but language server is shitting itself. All right. Do we have a new line in there? No. Okay, so he does have a known uniform location for all three. That's good. Is it possible these indexes surely are getting in there? Can we try something silly here and say if index is greater than 10, just hard code that shit in the fragment shader. can we make this like a vec4 1.0, 1.0, 1.0, 1.0, right? I just want to see like some evidence that the indexes are getting passed bar by bar, and it looks like they're not, right? Index here never seems to be greater than 10, which means that the inputs here in the vertex shader are probably wrong. And it's actually because we're just not passing it along. We're supposed to go, here, we're supposed to say like index is equal to v index. It has to get piped through from the vertex to the fragment shader. Okay, so that's good. So we see a bunch of purple on the bottom left here, followed by white everywhere else. That's kind of cool. So now we should be able to go back to doing this the correct way, which was that the active color is used if index equals hovered index. And so here we do see in the corner here a little white thing, which is hype. So looks like that is working. Now I don't like that the active color is white, but we might not be assigning it, which is probably part of this. So here we need in our uniforms, we need active color here. Which we can kind of do here. We can say active color v4 comes from active color. Okay. So now it should be that highlighted piece is a more sane color, which it is, right? We can see that shit here. Looking pretty good. Looking pretty good. Okay, so now the last piece of this part is that the hovered color needs to come from, or the hovered index needs to come from our like mouse position, right? So someone somewhere is going to find that thing. So we need to handle input state, I guess, is the answer. All right. So this guy, we need input state, input response here. Input response, bang, bang, boom. Okay, so this guy does know where he is. So what is like the expected order of operations here? I wonder if it's update then input or input then update, because that kind of matters. I think. Because if it's update then input, then we know where we like understand how many bars there are, and it is update then input is the expectation here. So at this point, it's like we know how many of these we have. Num buckets. I guess it doesn't really matter too. If we were at one frame before, it's like if we should have the number of buckets at 0 unless it's not 0. Whatever. Okay, so here we must be able to take like our input bound. Surely like the mouse position is interesting in some way here. If like input bounds contains mouse position, probably we don't do anything, or like if so. So if the mouse position is not in here, we don't do shit. What is it pissed about here? What the fuck is going on? I guess here we probably want to clear hover. Probably. I think also this like cint stuff, I think i32 is like totally valid here. I think that we saw that GL int is defined to be an i32, I think. So here we like clear the, we need self. We need self. We clear this. -1. It's fine. Then what? Then what? I assume that like we don't actually need the widget bounds. I think the input, I think it's like widget bounds is so say that you like you have a widget that's like larger than the window, that you're in. I think this is the widget bounds, and this is the input bounds, right? So like there might be stuff where the widget like is technically part, like it's there, but you can't interact with it, right? So that's why those two things are separate. So I guess it should be widget bounds is what we're working with here. We're looking at like left and right, probably, right? So we're probably looking at like the mouse pause X. Probably. Is this a float? It is. Mouse X. I don't know why it's a float. I don't think it can ever be like non-pixel position, but fuck it, I guess. What is left and right here? I32, yeah. Okay. So we have like some mouse position. We probably want to do like hold on. This times num buckets over widget bounds width. I'm pretty sure this is it, right? So we take the ratio of like how far into the widget we are, then multiply by num buckets, and then we switch the order because integer math. Yeah, that seems right to me. And then what's he pissed about? I32 and U size. Because num buckets, we'll just make this an I32. And then we have to set num buckets, so you know, too many buckets. Okay, this guy wants truncating division. Okay. Then here, we never ask anything to happen. We only use input for display. So we say, just return the default. Who gives a shit? Okay. Not happening, because hovered index here is not being passed along, where this needs self-hovered index. It needs to be passed to the GPU for highlight. Look at that shit. You guys see that shit? It's pretty sick. Pretty fucking sick, dude. And then if I hover over the text above, it doesn't do anything, right? So it's kind of hype. Kind of hype. So I think all that's left now is axes. So I'm trying to decide what I want to do here. We're at 2 hours, which is like kind of where I want to call it for YouTube video. So I think what we do is we split this and we say YouTube gets up till here, and then we'll say an exercise for us in happy hour is to finish off axes and ranges, which shouldn't be that much. So guys on Twitch, stick around. We're gonna keep going. YouTube viewers, thanks for watching. If you like what we saw, we stream most days 12:30 Pacific time to 4 Pacific time. It is, 2:30 now for you live viewers, so anywhere between 2 hours or 2 hours ago and an hour and a half from now. So when you should expect to see us live. There's a YouTube link in the description where, some portion of the VODs end up. The rest end up on Patreon, YouTube members, or Twitch. If you provide support in the appropriate places. The reason that we do it that way is we want something to give back to people who help the stream continue, as well as there's like a type of content that fits well in the YouTube algorithm. We're trying to like somewhat scope the channel to that stuff. So please consider supporting. The stream stops happening when I run out of money. And so if you support, you get the rest of the VODs and the knowledge that the stream can go for some amount longer. Okay, YouTube, peace out, and Twitch, let's keep going.